Did they save the most annoying derivatives for last? Yes. Yes, they did. Our function here is x plus 2 over x squared. And if we're going to do its derivative, we need f of x plus h, which is going to be x plus h plus 2 over x plus h all squared, which, if we expand it, I think it's better to expand it, is x squared plus 2xh plus h squared. Okay, so our derivative is the limit as h goes to 0, f of x plus h minus f of x all over h. Two fractions must combine, common denominator. So this first fraction needs an x squared to get a common denominator. There's an x squared, and there's an x squared. This second fraction needs x squared plus 2xh plus h squared, excuse me. 2xh plus h squared over the same thing. And what do we get out of that? X cubed plus x squared h plus 2x squared. Now, this minus applies to everything that's about to come out here. X times x squared, x times 2xh, x times h squared, 2 times x squared, 2 times xh, and 2 times h squared. Sorry, that, even for how small I'm writing, that should look better than that. All that is over x squared times the trinomial and it's also over h. I'm going to fit in a 1 over h on the extreme right here. Can we cancel anything? We have, not a lot of cancellations, are there? X cubed minus x cubed, that's something. And here I see 2x squared and minus 2x squared. Those can go. I think that's it. And we have some x squared h's we can combine in the next line. X squared h minus 2x squared h is minus x squared h. We get minus xh squared minus 4xh and minus 2h squared. Now, all of those are divided by h. I'm just going to do that right now. This h goes, this h, one of them goes, one remains. This h goes, and of these two h's, one remains. And all that is over x squared plus 2xh plus h squared. Now, this is the limit as h goes to 0. So all the terms which contain h are going to vanish. That term vanishes, so does that, so does that, so does that. Which means this cleans up to minus x squared minus 4x over x squared times x squared again. That's your derivative. You could divide the entire thing by x if you wanted and get minus x minus 4 over x cubed, and that could also be your derivative. I'll use that one. It's nice to clean up derivatives as much as possible. So that's our derivative. They're asking about what it does when x is 3. So we can plug that in and get a slope value. The slope will be minus x minus 4 over x cubed, which is 3 cubed, which is 27. So minus 7/27 is our slope. Now, I'm hurting for space here. I'm going to use this top corner, I hope, to work out the tangent line. So our slope is minus 7/27, which means our tangent line is y equals minus 7/27 x plus something. And we want that line to hit 5/9. 5/9 equals minus 7/27. X is 3 plus b. I'm going to get a common denominator of 27 because I feel like I'm going to need it. So triple this fraction. 5 times 3 is 15. 9 times 3 is 27. Equals, over here we get minus 21 over 27 plus b. Add 21/27 to each side. b is 36/27, which is actually just 4/3. So our finished tangent line is y equals minus 7/27 x plus 4/3. Sorry for the squeeze. Derivatives from the first principles take up a lot of room.